All right. So we've done the rice test now, and the rice test proved that you could fit 3 cones into a cylinder with the same size, base, and height. And it's also that worked for rectangular prisms and rectangular pyramids, and it worked for triangular cones, triangular prisms and triangular pyramids. And that is because, if you notice on here, you can actually take a rectangular prism and divide it into 3 equal triangular or 3 equal pyramids. And then those pyramids out, you kind of have to imagine this, that you can put those 3 different pyramids into this prism and it's going to be the same size. So the space inside can be split 3 ways. And so because of that, the volume formula for a prism, for a pyramid and a cone is going to be 1/3, capital BH. Do everything that you would normally do for the volume of a prism or a cylinder, and then divide your answer by 3. Okay, divide your answer by 3. That's it, because again, it took 3 cones in a cylinder and 3 pyramids inside a prism. So for example A, here's my volume formula, 1/3, capital BH, which means I have to be able to know the difference between a prism and a pyramid. Otherwise, I'm going to use the wrong formula. The area of my base is 3 times 4. The height of the pyramid is 7. And so if I just did 3 times 4 times 7, length times width times height, that would give me the entire prism, which I do not have. So I divide my answer by 3 when I'm done. Or the reason I like writing 1/3 in front is because I can actually, instead of waiting till the end, I can get rid of the 1/3 right away. What's 1/3 of 3? 1. So I'm just doing 4 times 7. What's that? 28. And then because it's volume, remember we said volume is feet cubed. Feet cubed. That's why I like writing the 1/3, because I can get rid of that 1/3. Just like if I had a half and I had a 2, I can cancel them out, or a half and a 4, I could reduce. I can get rid of the 1/3 here if I have a number that 3 goes into. Let's look at example B. Let's put you down here. This is a triangular pyramid. So the base is this triangle right here that you guys see. My formula for any pyramid is 1/3, capital BH, and my capital B is going to be, well, the area of that triangle. Now, remember the triangle formula already has a half. So I'm going to be quite honest with you. The problem that is missed the most on the volume quiz Friday is one like this. Because people will put the 1/3 and they'll forget the 1/2. That's already part of the triangle formula. So 1/3 times, to find the area of that bottom triangle, 1/2 times the base, 17.5, times the height, 6. Still need to slide this over. And then the H, so all of this that was in parentheses, I'm going to try to do a better job of highlighting this using my special tools. Everything in parentheses is capital B. Capital B just has to adjust. Last time it was a rectangular pyramid, so that was super easy, length times width. But this is a triangular pyramid, so I have to include the 1/2 in it. And then the H on the outside is the actual height of the pyramid, which is 10. Now, you might remember last week when we were doing surface area, we used L, didn't we? I do not need L, the slant height, if I don't need to find the area of the lateral triangles. I do not need to. So the difference between L and H is going to go straight up and down and tell you the height of the pyramid from the center of the pyramid down to the bottom, whereas L is going to go like this, from the top slanted to give you the height of the slanted triangles, which I need for surface area, but not for volume. So no L's this week. Okay, what's 1/3 of 6? Okay, and what's 1/2 of 2? So I guess I could just go ahead and scratch all 3 of those out. I'm really just doing 17.5 times 10, aren't I? So if you already did this and you're waiting for me to get the answer, did you get 175? There you go. That's why. That's why you're getting 175. It's because 1/3 times 1/2 times 6 all cancels out. And that's going to be meters cubed. Thank you for the 2 of you that said that. Hopefully all of us will say it next time. Now we have a cone. Cones use the formula 1/3 BH, just like all the other pyramids do. It's just that B is going to go ahead and change to the circle formula, which is pi times radius squared. Jace, what's the radius of our circle?
4.
Not 4. That's the diameter, 2. Okay. And then the height of the cone is going to be 6. Dawson, what's 2 squared? 4. And what's 4 times 6? And what's 1/3 of 24? All of that simplifies to 8 pi. And if that was too fast for you, you could have just said 1/3 of 6 is 2, and 2 times 2 times 2 is 8. I still need to go ahead and round this to the nearest. Did it say? It didn't say. I believe your homework tonight for the cones homework. Of course, all the pyramids are going to be on one, and all the cones will be on another one. I hate that. But I believe it says round to the nearest 10th. So let's times by pi and just use 1 decimal place, because I'm pretty sure it asks you to do that in your homework. Okay, so Dawson, what do you get for 8 times pi rounded to 1 decimal place? Okay. Oh, nice job. Thank you. 25.1 meters cubed. On your quiz Friday, you can round to 2 decimal places. That's not going to be anything I care about, but I know big ideas. If it says 1 and you put 2, it's going to say it's wrong. It's not wrong. It's just not the answer I was looking for. And so if you put 25.12 for me, that's fine. I'm not going to take off for that. Here we have another triangular pyramid. So here's my pyramid formula. And I'm going to, I'm going to let somebody else do this actually. Chloe Sheasley, can you tell me what numbers you would multiply together to find the area of that base triangle? Okay, 7 and 18. Anything else? Yes. Yes, so 1/2, that's already there. Well, it's not already there. I have to put it there, but it's part of the triangle formula. It's a bad looking too. There we go. And then the height of that pyramid is 11. Let's see if we can eliminate our fractions, because many times we can't. Sometimes we can't. Many times we can't. Can someone tell me what half of 18 is? Standard?
No.
And what's 1/3 of 9? 3. So we can get rid of the 1/2, the 1/3, and the 18 and just call it 3. Of course, 1/3, by the way, 1/3 times 1/2 is 1/6. So it's really like you're just doing 1/6 of 18, or 18 divided by 6, which is 3. Then I'm going to times that by 7 and then 11. And again, I know you can use this in your calculator. I'm trying to save you as much time as possible. So if I do that in my head and I get 3, then I can do 3 times 7 in my head. What's 3 times 7? 21. The only thing I have to plug into my calculator is 21 times 11, if you don't know what that is. So 21 times 11 is the only thing I have to type in. And I get what? 2 what? 231. And that's going to be centimeters cubed. Not a hexagonal pyramid. Oh no.
I don't know, Maddox. You tell me.
Well, fortunately for us, they're giving us 90% of the work here. They're telling us that capital B, whatever the formula is for a hexagon, don't know it, but whatever it is, they're saying it should give you 48, because that's what capital B is. So I'm going to plug 48 in for capital B. The height of that pyramid is 9, and so I just have to do that. Lizzie, what's 1/3 of 9? And so we're just doing 3 times 48, which is okay. And what would the label be? That's right. Now, why did they put millimeters squared here? That can't be right. Why did they do that, Seth? Yeah, that was the area. You're right. When I times by another millimeters, that's going to give you my millimeters cubed. Yeah, that's going to get. So my final answer should be millimeters cubed. All right, example F. Here we have a cone. Yeah, Lizzie.
This is probably wrong, but the hexagon area be 6 times whatever the width of one side is.
I believe you have to take. There's something called the apothem, and the apothem is like the radius of a regular polygon. But it goes basically from here, and then you go right out there. And so you need to know what the apothem is. And then the formula is like 1/2 times the apothem times, oh goodness, I could Google, I'll get back to you on that. It's been a while since I've done it. And so because I don't use it very often, I've forgotten it. So I'll get it after class. I can tell you what it is. If you really want to know, I can tell you. I know that because for my math bowl team, we had to do that one year. And so we had to learn the formula. So yes, Owen? You know, that would be a good way to do it. What Owen's saying, if you took a hexagon and split it right down the middle, that'd make 2 trapezoids that are, if this is a regular hexagon, and that means that all the sides are the same, and all the interior angles are the same, then you would just be able to find 1 trapezoid and double it. We would need to know, however, how long that green line is, because that's our B1. We'd also have to know what our B2 is, and we'd have to know what our height is. And I don't know any of them right now. So I wouldn't be able to tell you. And again, I don't need to, because it already said what the area of the base was. But yes, that'd be a good way of doing it. You guys are very interested in that. I like that. Again, that's what an advanced class should be. Trying to figure out the difficult questions, not just doing the easy stuff and moving on. Person?
And then from there, then we could at least assume that one of the trapezoids would have an area of like 24.
Yeah,
And so
well,
then we probably could do all of this. We could probably find like.
You
the
could-
height of the base
you
and
can,
stuff like
you couldn't be sure, because you have to have 3 different numbers, the height, B1 and B2, but you could give some possible answers. You're right. If you split that right down the middle, that has to make that 24, has to make the other one 24. That's where we get the 48 from. So you're right. We could get close to estimating what those numbers could be. Example F. 1/3, capital B, H, capital B. What are we gonna plug in for that, Xander?
1/3, yeah, 5, 6 squared.
That's right. Xander, what's 6 squared?
36.
Okay, now, I've been showing you guys a way that you can kind of do this in your head. What you can't do is 1/3 of 6 right now, because 6 is being squared. And order of operations says that exponents is more important than multiplication. So I'd have to square first. Now, if you wanted to do 1/3 of 15, you could. What's 1/3 of 15? 5. So you could do that. You can't say 1/3 of 6 is 2 and then square that. That's not going to get to the same answer, because you got to square that 6 first. So we could say this is 5. We know 6 times 6 is 36. And so I'm just doing 36 times 5 times 5. Martin Doan, I'm going to have you give me the answer for that. 36 times 5 times pi. Okay, and let's round it to the nearest 10th. Nice job. Centimeters cubed. You got it. Nice job. Literally everything I'd want right there. Yes.
Do the extra and then divide 36.
Yes, and that would give us 12. Yes. And then we do 12 times 15. You know what 12 times 15 is going to give us? The 180 that we needed for the pi. Yep, that would work as well. Yep, square it. I just thought it'd be easier to do 1/3 of 15 than it would be to do 1/3 of 36. But yes, you can do that. All right, let's move into the more interesting problems. And I know we only have 2 minutes left, so we'll just get this one done and we can do this next one in class. There's two. Well, fortunately, tomorrow's only one shape, so that's going to save us half the time with just a sphere again. But anyways, we'll do this last one here. The height of the cone, round your answer to the nearest 10th. So the cone formula requires this formula, 1/3 capital BH. And then I can plug in for capital B if I know the radius. Oliver, do I know the radius? What is it?
9.
Okay, so 1/3 times pi 9 squared times h. I also know the volume. Oliver, what's the volume? Yep, that's given to us because we're not worried about finding volume. We're worried about finding the height. So in order to solve this, I need to simplify. Connor Kendall, tell me what 9 squared is. Okay, oops. And Connor, can you tell me what 1/3 of 81 is, or 81 divided by 3? 27. So I'm able to simplify the right side of the equation all the way down to 27 pi times h. And if I want to get h by itself, I just need to divide both sides by what? What would I be able to divide by to get rid of the, well, to get h by itself? Carson?
You have to divide 956 by 24, divide both sides by 27.
And pi. Yep, that's not a good pi symbol. 27 and pi. And so I can do that in one step, just using my calculator twice. 956 divided by 27 equals, divided by 3.14 equals. And that's going to give us an approximate answer. So there's my squigglies. And it says nearest 10th. So I'm getting 11. I don't know about you. I'm getting 11.2762 something, 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 something. If it says nearest 10th, that means I need to look right here. The 100th digit is going to tell us whether the 10th digit bumps up or stays the same. Is this closer to 11.2 or 11.3? 11.3. And what's my label going to be since I'm just finding height? Feet. Feet, 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 only feet. Feet, only feet. I've already got the feet right there. We will stop there today. Again, enough for you guys to go ahead and get started. This homework, like yesterday's, is on 2 different big ideas. You can do it on 1 paper though. And Prism and cylinder homework tomorrow. Email me if you have questions. See you tomorrow. You guys are free to go.